Assalamu alaikum guys, welcome. Alright guys, so in this video we're going to talk about hybridization. How are you going to determine hybridization? Okay, I'm just going to give you the important information that you are supposed to note in order to clear your exam, and in order to the stuff that you actually require in your syllabus, and not the extra details of hybridization. Okay, because hybridization on itself is a very huge topic, but we don't need to know everything, every single thing in hybridization. Okay, so let's just stick to the syllabus and let's complete this. Alright, so first of all, what does the term hybridization actually mean? Hybridization means mixing of orbitals. Okay, for example, if you've got an s orbital and a p orbital and you mix them together, you'll form a hybrid orbital, which is known as an sp orbital. Okay, if you've got one s orbital and two of the p orbitals, any two p orbitals, px, py, pz, px, anything, and you mix them, you form an sp2 hybrid orbital. Okay, sp2, the 2 represents the number of p orbitals which are there. And then if you've got 3 p orbitals and 1 s orbital and they're mixed together forming a single orbital, a single hybrid orbital, then it's going to be sp3 hybridization. Alright, the hybridization in our syllabus is for carbon. Okay, carbon atom. So now let's get started. It is necessary for the formation of covalent bond in carbon in certain elements, and the carbon is our classical example. Okay, now this is I've just explained how hybridization, the concept of hybridization for sp3 hybridization over here. I'm not going to go into the concept of sp2 or sp. Alright, so now let's just talk about sp3 hybridization. So carbon has a proton number of 6, 1s2, 2s2 and 2p2. Now in this hybridization, in this electronic configuration, this is the sort of configuration that you are supposed to expect. Okay, meaning I've just chosen the outermost electrons, the 2s2 and the 2p2, because the outermost electrons are actually involved in the formation of a covalent bond. Now you've got the 2s2, so this is the 2s orbital and the 2p orbitals. Okay, these are the 2s and the 2p orbitals. Now in the 2s orbital you've got 2 electrons, and in the 2p orbitals you've got 2 electrons, but half of both the orbitals are filled following the Hund's rule. Now in hybridization, what we actually need to do is we need to bring the 2p orbitals and the s orbital, we need to mix them. When we mix them, the 2p orbital is at a higher energy level and the 2s is at a lower energy level. After mixing, a hybrid orbital will be formed, which will be at an intermediate level in between the 2s and the 2p. Okay, so it's gonna be somewhere over here. Alright, so mixing, I've just I didn't draw it over here on the dotted line, but rather I have shown them over here. How are we going to mix them? Well, for mixing we'll have to give a certain amount of energy to this electron at the lower orbital. Okay, in the 2s orbital, once we provide some energy to this electron over here, this electron will be excited to a higher energy state. Okay, as soon as we provide some energy, some external energy to it. Okay, you provide some energy to it. After providing energy, this electron is excited to a higher energy level, and as soon as the electron is excited to a higher energy level, this orbital becomes half full and that orbital also becomes half full. So all the orbitals have now become half full. Once all the orbitals have become half full, they come at an equal energy state. Okay, they come at an energy state, meaning their energies of all the orbitals become equal and become intermediate between the 2p and the 2s, and this is how they look like. This is the hybrid orbital that is formed. This is called, since it was formed by the mixing of all the 3p orbitals and one s orbital, so it's gonna be, all the orbitals are gonna be sp3 hybridized, because it contains 3 p orbitals and 1 s orbital. Now if you look at the orbitals, they are all half full. If they're half full, this means that they can actually form single covalent bonds with other molecules, right? And if they can form single covalent bonds, so one covalent bond can be formed here and here and here and here. So this means that carbon atom having 4 single covalent bonds will have an hybridization of sp3. Okay, if you look at methane over here, the methane molecule that I have drawn over here, in this the carbon atom has 4 single covalent bonds. How were these 4 bonds made? Well, what it actually did was it hybridized its orbitals, forming 4 sp3 orbitals, and now each of these orbitals formed or overlapped with the with the s orbital of hydrogen. Okay, so this overlap is gonna be the sp3 s orbital. Okay, sp3, because the carbon is an sp3 hybridized orbital and the hydrogen has an s orbital. Simple, this was the basic concept. So if I were to ask you that what's the hybridization of carbon in this molecule, so it's going to be sp3 hybridization. Now this was the concept of hybridization, and by the way, if you ask, if you look at the past year papers and the syllabus and the examination, the examiner won't ask you all of this stuff. What will the examiner actually ask you? If you look at the past papers from the last 10 years, this is the stuff that's the examiner gonna ask you, the last stuff. Tell me the hybridization of carbon atom in methane molecule, or tell me the hybridization of carbon atom in ethene molecule or in carbon dioxide molecule. So how are you gonna tell the examiner the hybridization of carbon atoms without going into the detail of hybridization? So this is what I'm gonna explain you in this lecture, the trick to finding the hybridization, the short trick basically to finding the hybridization. So now basically what you actually need to do is, you need to first look at the number of electron densities around the carbon atom. This is the carbon atom. How many electron densities does it have? Remember, electron density can be a single covalent bond, it can be a double bond, it can be a lone pair of electrons, okay? These are three different types of electron densities. It can be a triple bond, it can be 4 bonds as well, a single electron density, okay? So now over here, we've got 1, 2, 3 and 4. 4 single covalent bonds means 4 electron densities are there around the carbon atom, and 4 electron densities mean that 4 orbitals will be used to form the hybridization of this carbon atom. 4 orbitals have been used to form the hybridization of this carbon atom, and 4 orbitals are actually present in sp3 hybridization, meaning there are 3 p orbitals and 1 s orbital, so a total of 4 orbitals are there. So therefore this carbon atom has an hybridization of sp3. Similarly, if you had another molecule, let's say CH3, CH2, CH3, propane. In propane, what's the hybridization of this middle carbon? How are you going to do that? Well, again, simple. Just look at the electron densities around the carbon atom. This carbon atom has 2 single hydrogen bonds, right? 2 single bonds with hydrogen and 2 single bonds with the carbon atoms next to them, right? You just need to look at the immediate covalent bonds of this carbon atom. There are again 4 regions of electron densities, so this carbon atom is also going to be sp3 hybridized. In fact, every carbon in here is sp3 hybridized. This carbon is also sp3 hybridized because it has 4 covalent bonds, 4 single covalent bonds. This is also sp3 hybridized because again 4 single covalent bonds. Okay, so this was the trick to finding the sp3 hybridization without going into all that detail. Now coming to the ethene molecule over here, what's the hybridization of this carbon atom over here, or that carbon atom? So let's first talk about the left one. Okay, in the left carbon atom over here, you've got how many electron densities? 1 single covalent bond, another single covalent bond, and these are not 2 single covalent bonds. This is a double covalent bond over here, okay? And 1 double covalent bond is a single electron density. So in total, there are actually 3 electron densities around this carbon atom. 3 electron densities mean that 3 orbitals will be used to form the hybridization of that carbon. So sp2 contains 3 orbitals, meaning 1 s and 2 p orbitals. So sp2 is the hybridization. Again, the same applies over here. sp2 is the hybridization. Now coming to the carbon dioxide carbon atom. This carbon atom over here has 2 double bonds. 2 double bonds do not mean 4 regions of electron densities. 2 double bonds mean 2 regions of electron densities, because I told you that 1 double bond is a single electron density. So this is gonna be sp hybridization, meaning 2 regions of electron densities mean 2 orbitals will be needed to form the hybridization of carbon dioxide. Okay, so this is a short trick of finding the hybridization of an element without going into the details, right? And this is literally everything you need to know about hybridization. Every single question will be solved using this trick. Okay, for example, now other than carbon atom, oxygen, or if you have oxygen over here, what's the hybridization of oxygen in water? What's the hybridization of oxygen? Okay, some of you might say that there are 2 regions of electron density, so therefore it's going to be sp hybridization, but I guess that's not the case. Oxygen also has 2 lone pairs, remember? And 2 lone pairs, and I told you that a single covalent bond or a double covalent bond or a triple covalent bond or a lone pair, all of them are separate electron densities. So you've got 1, 2, 3 and 4 electron densities in here. So the hybridization of this oxygen is actually sp3. Clear? So, well, oxygen won't come in your syllabus because it's not part of the syllabus, but carbons will actually show up. So this is how you do it. Thank you.